in some normal setups, we normally can't get data which is like sample sizes which is not more than 30 or even 30. For practical reasons, we get samples that are like quite small, like sample size is like around 5, so let's just call it sample size of 5. So it's really hard to achieve that 30, but we don't have any problem, even though we know that this is not going to be a normal distribution. Like the sampling distribution of the sample means won't be a normal distribution, but we know that for small sample sizes it's gonna be a t distribution. A t distribution. So now let's say that we indeed know that it's going to be a t distribution, but our problem now is how do we remember that a t distribution can be written as such really thick tail, kind of looks like a normal distribution, but just thick tail. If I would again superimpose a normal distribution, we know it looks like that. Alright, the white one is the t distribution, so the white one is the t, and the yellow one is the normal distribution. Alright, my point is, how do we calculate a specific probability for a specific statistic? So let's say we wanted to calculate what's the probability of getting this. Let's call this ti. What's the probability of getting t values more than ti? And remember, the way that we do this in normal distribution is like if it was to be done in normal distribution, we just need to get that area, which we know we just need to go for cumulative distribution function. Well, can we do the same with t-distribution? Yes, indeed, we can do the same for t-distribution. For t-distribution, of course, we need to get that area. So we just need to do its own CDF. So what are the things that we need? When I was doing the Excel, like back then in the first video, it seems to be that the function is written as equals sign t distribution, and it needs 3 parameters. The first parameter is the x statistic, which is kind of easy. The x statistic. The second parameter is the degrees of freedom. Now this degrees of freedom is actually related to the number of samples. Degrees of freedom for a simple t distribution is just equal to n, which is the sample size, minus 1. So that makes our life really easy. And finally, we have the cumulative function in here. So if you wanted to make it a cumulative function, this argument needs to be true. Alright, and this degrees of freedom needs to be n minus 1, and the statistic needs to be the values xi, which you would supply. So let's take a look at an Excel program that I did that demonstrates this, so you understand how you would use a t-distribution if it's the case that you have a small sample size.